Hello everybody, I'm Victor.
Hello everybody, I'm Per. Welcome to Jungle Ranch.
We were advised to do an ultimate lofting guide video.
In this tutorial we will show a new method how to calculate a new table of offset with reduction for planking.
This new method is much easier and faster, and it requires a lot less lines in the lofting table.
We will also show how to do a lofting table.
Without further ado, let's get to it.
In this ultimate guide in lofting, the AI voice Andrew will be used. That's me, and some clips with our real voices. If you want to read more, there is a list of suitable books in the video description. This ultimate guide is divided in some chapters. The chapters are 1. History of lofting. 2. What is lofting? 3. How is lofting used? 4. Digital lofting. 5. How to calculate a new table of offsets with deduction for planking. 6. How to make a lofting table. 7. How to draw the grid lines. 8. How to mark the points and draw the lines. 9. How to make and cut the molds. 10. How to check the molds on the lofting table. If you want to jump to a specific chapter, you can find the chapters in the description. 1. History of lofting. Let me explain the history of lofting. The lofting technique is more than 500 years old. They really don't know how old it is. The name lofting comes from when they built a loft because there was no space for floor drawings. The loft gave them a lot of space to do full-size floor drawings. They called it lofting. 2. What is lofting? Victor will now say some words about lofting.
Lofting. And we'll get to the history of the lofting and how lofting is done and how it serves the purpose of boat building. However, this is not an easy topic to talk about. It's not easy to describe, it's not easy to use, but it's a very powerful technique that helps us build boats in a better way.
Lofting is a modeling technique used to create a 3D shape by defining a series of 2D cross-sectional profiles, called lofts, and then generating a smooth surface or solid that transitions between them. Lofting is not used only in boat building, but also in aircraft design, automotive design, and 3D modeling. In boat building, lofting is the process of drawing the full-sized plans of a boat or ship on a flat surface, often a large sheet of plywood or the floor of the workshop. It is used to precisely transfer scaled-down plans into full-size templates for cutting materials. Well, this sounds simple, but in reality, can be really difficult. Furthermore, it is very easy to do errors as there are so many lines. Lofting is the same for all boat building techniques, with some minor difference. There are several types of boat building techniques. However, 2 types of building are more common. Molds on a keel, backbone, etc., with steam-bended frames. With molds on a keel, you loft the wooden molds. These are temporal molds and will be removed in a later stage. The pictures shown here are examples from Bud McIntosh's book, How to Build a Wooden Boat. In this type of building, you have a so-called rabbet line. The rabbet line coordinates can be in the table of offsets or can be found in the construction drawing. The other common type is frames on a ladder, upside down, with station cut to shape with help of a mold based on the lofting. In this building technique, you loft the stations which are mostly not temporarily. 3. How is lofting used? Victor will now explain how it's used.
Lofting es una técnica muy importante que nos ayuda a llevar algo de tamaño a escala. Supongamos que esto es un bote, este es el motor y esta es la parte superficial del bote, es decir, la cubierta donde van las personas, y llevarlo con este nivel de especificidad de cada bote, llevarlo al tamaño real, o sea, para poder hacer esas piezas con las que vamos a ensamblar todo el bote. Entonces, estos pequeños detalles que nos muestran los planos, los vamos a poder ver en grande. Los vamos a poder hacer en tamaño real, una pieza por otra, para después ensamblarlas.
Whatever type of boat design, there are usually 3 types of major planes: body view, profile view, and half-breadth view, plus a table of offsets. Of course, there are other drawings describing various things. Body plan view. The body plan is usually presented as a separate drawing, but can be in the construction drawing. Example of this is Bud McIntosh, who incorporate the body plan around mid-station in the construction plan. The body plan is longitudinal slices of the boat at equal distances called stations. The distances between the stations depends on the design and are different depending on the design. The body plane consists of a baseline and a vertical axis. The baseline is often below all stations but can be located at the so-called design waterline, where the real waterline is supposed to be in a defined loaded state. A grid system is used by defining horizontal water lines with different distances relative to the baseline like 12, 18, 24, 36, 42, 52 inches, and more. The vertical lines seen in the picture are called buttocks lines. These lines are simply vertical lines in reference to the grid system vertical line. The distances can be the same as water lines like 12, 24, 36 inches, or more. The diagonals are a little more difficult. They are usually not 45 degrees and not always inclined equal. How they are defined depends on the designer. In the picture you can see that the diagonals have different angles as well. Usually, they are defined on the drawing with notes stating the location or are drawn to a measured distance. In the table of offsets, states the distance from the vertical line along the diagonal. Note, all stations forms are outline of the boat. When making station in whatever method, you must deduct for the planking. This create additional lines in the lofting. However, in Chapter 5, we present a method how to calculate a new table with deduction for planking. This means much less lines on the lofting table. We are the only boat builder using this method. You are welcome to copy our method. Profile view. Most plans show the boat facing right, so the profile is what you see from the right side. The profile is generally bounded on top by the shear line, at the bow by the curve of the stem, underwater by the keel, and aft by the transom, with buttock lines showing the shape of the hull from the center line outward. Profile view shows vertical slices along longitudinal of the boat. In this you can again see the baseline, however not shown here due to copyright. Key components in profile view. The shear line, the longitudinal curve of the deck from bow to stern. Buttock lines, curves that show how the hull is sliced vertically, parallel to the center line. Water lines, horizontal lines showing where the water surface intersects the hull at various load. Inboard profile, a version of this plan that cuts away the side of the hull to show the internal layout, like engines, cabins, and fuel tanks. Half-breadth view or half-width. This is a plan with horizontal longitudinal section. The half-breadth views like the profile view, but in an opposite plan. In this drawing, you can see the shaped water and diagonals lines and other shapes of the boat. Table of offset. All plans described are based on the table of offsets. In the table of offsets, there are measures for shear, intersection with the deck, water lines, buttock lines, profile point versus station, and much more, depending on design. For boat building frames on keel, there is usually data for the rabbet line. In the picture, the profile is called C/L of fair body. Also, there is a definition of a chine profile location and intersection with cabin/deck. Usually, the measures are stated in feet, inches, 1/8 inch, or decimal of feet. We always translate all into millimeter measure. Note, there can be errors in the table of offsets. To detect and avoid these, you should use Microsoft Excel to plot the shape per station and compare with digitized values. We use Get Data Graph Digitizer, but there are many other similar software. With a JPG file of the plan, you can see small details not visible in a normal picture. In Chapter 4, we explain further about this. 4. Digital lofting. Per will now show how we use our software Get Data Graph Digitizer.
In this digitizer, we can see very small details and measure them. In this software, you can calibrate the drawing for a known distance in X, for example, between 1 and station 13. The same in X is set. You have to have a certain distance here to calibrate it. How good the calibration is depends on how good the drawing is. I can measure the location, I will show here, of the bulkhead, the size and the location and distance from the center. I can even measure the thickness of plywood. I prepared here a measurement. I will show you. I will make it big. Where is it? Here it is. Here, I took 2 points here, and you can see here, that becomes 13.8 millimeter, and it's pretty good because you have to remember this is a slight error in the drawing and the copy. In the whole total, it's good. If you really want to have even better accuracy, you can calibrate over the station. That's easy.
5. How to calculate a new table of offsets with deduction for planking. Bud McIntosh method is to make arcs with radius equal of the deduction. But we calculate directly a new table of offsets with deduction for planking. This considerably reduced the number of lines on the lofting table. Per will now explain how this is performed.
Here's the data from our table of offset for our station 5.5. As you can see, I have arranged the data from profile to shear in from low to high values. As usual, in table offset, there are always some small arrows. As you can see in the curves here, here's the curve for the lower part and for the upper part. You need to do two fittings because it's a curve station. One from profile to the midpoint, or from the midpoint to shear. In our case, that is the shine for us. And then you have the labels, the trend line labels that you have to adjust to scientific and 6 decimals. If you have a third polynomial, you can use 10. Do not use more than third polynomial.
Very short, we will show a summary of this first step in calculation of the deduction. Per will continue now.
Now we must use this and make a two new columns. Here I call it regression. Here is the x values, the same as the table of offset, and here in the second column I use a function you can see here. The lower one is up to the shine, and the upper one is from here to the shear. Now it's time to calculate the angle at the local point. For this, we use the arctangle function. I can show you here to calculate that. And here, I did a derivate. Here was a square, and you put that square 2 or 3 in the third polynomial in the front. Don't change the sign. And here you take away the x value was only 1 in this case. And then you can see the function in here. I summarized this here.
For clarity, we show a summary of this second step in calculation of the deduction. Note how to do the derivation. In a second polynomial, a number 2 is multiplicated with the first equation constant, and the second constant will not have any variable dependence. In a third polynomial, there will be a number 3 multiplicated with the first equation constant, and a number 2 multiplicated with the second equation constant, and the third equation constant will not have any variable dependence. Per will continue now.
Plotted, this will look like this when you plot the regression, the x values versus angle, and I call alpha. And you can see there is a difference in angle here and here. That's partly due to the function of arctangle's function. In order to get correct angle of deduction, you need to do according to this formula I will show here. And we need to create 2 new columns, this x and z values, and calculate according to the formula I show here. And now you may see a negative value in the first cell. That will be fixed later on, because if we use these values to calculate a new table of offset.
For clarity, we show a summary of this third step in calculation of the deduction. Here you can see the equation of a new angle, half pi minus the previous angle. The x deducted value is x regression minus planking thickness multiplicated with cosinus of a new angle. And the z deducted value is z regression minus planking thickness multiplicated with sinus of a new angle. We'll continue now.
Note this column that is named check. You can see the values varies a little bit. The lowest is 29, the upper is 40, it should be 34, all of these. That's because here is taking a comparison deduction directly to the table offset. But it should be the regression values, like this. If I now copy down this to all values here, we get 34, whereas our deduction for this station. Now you can see you can have one cell that has a negative value, not a problem. We will use these values like this, make a regression, the same as before, and now change the label to scientific 6 for a second, like this, and the same for the other one here, except it will be shorter, include the midpoint, in our case the shine. And here I have done this here, and here's a curve. This regression now is a little bit different. For butter lines is a function, z is a function of x. For water lines is the opposite. X is a function of z. So that makes it a little bit tricky. Use the first function from profile to the shine, and the second one below the shine or midpoint to the shear, or do as you find reasonable to do.
For clarity, we also show a summary of this fourth step in calculation of the deduction. Note that graph has the same scaling in x and z axis, and the length of the axis are the same. This is to not get a wrong picture because of scaling and the graph type. You can copy from screen these 4 pages and paste in a Word document. This is the end of this chapter 5. 6. How to make a lofting table. Usually, the professionals build a full-size lofting table. If you have a very good and flat floor, you can fit plywood directly on the floor. Example of this is Samson Boat. There they build a full-size lofting floor. However, they had a problem with the edges between the plywood sheets. A solution to this could be to use screws for screwing directly in the floor. Example is the German spack screws. If you can't screw in the floor, then use Samson Boat solution with tape. However, the most private builders don't have that space, so they instead build a lofting table big enough for the stations in their build. Whatever, if you do full-size lofting of the whole boat, or just station, and other parts, you must have some sort of wire/beam or laser representing the middle of the boat in your build. If you install the stations correctly lined up as they should be, you will get the lines you can see in the profile and half-breadth views. Of course, there will be tolerances, and you will have to do something reasonable from side to side. A good tool to check the fairness of the installation is to make a long batten, slightly more than the boat length. With this you can find some misalignment. When you are finished with the process of lofting, you store away or destroy the lofting table. We at Jungle Ranch have solved it by raising up the lofting table. When building your lofting table, try to use as little wood as possible, but strong enough. You can use 2x4 frames and space each frame 600 millimeters. If you want to investigate how other boat builders made their lofting tables, just search in YouTube. Our lofting table in the picture is 3 by 2.7 meters, 10 by 9 feet, and made by wood frames of 40 by 75 millimeters, 1.6 by 3 inch, plus surrounding beams. On top of this is 12 millimeters plywood, screwed with Spax torque screws. The plywood edges are filled with something called ready mix and sanded. The table is painted with 3 layers of white paint. Calculated, the total weight of this table is about 70 kilograms. The lifting device is accomplished by 300 kilograms winch and 4 pulleys. 7. How to draw the grid lines. Let's assume you have a 3 by 3M large lofting table, or maybe you have a full-size lofting table with apportionment for the body plan. Now it's time to draw the grid system. First, you need to choose where to draw the horizontal baseline. Draw it 1 decimeter inside on the lofting table. After this, determine where you want the vertical axis to be located. Now you must take 2 distances to the left and right of the intended vertical line and swing arcs with a piece of wood. One end has a screw or a nail, the other end has a pin. Swing these arcs as you can see in the picture. Here we have used a 24-inch buttock point. Where these arcs cross, you have the mark for the vertical line. Use a straight ruler or similar to draw the straight line. Next comes the water lines. Most people swing arcs for these as well, but can also mark points to the and right on the line close to the edge of the lofting table. Never measure between the water lines. Now draw these water lines dotted with the same pen color as the baseline and the vertical line. Do similar for the buttock lines. The diagonals are slightly more tricky to draw. It's assumed you have determined how they are defined with 1 point on the vertical axis and 1 point as the drawing states. Draw these dotted as well with the same pen color. You will end up as the picture show. 8. How to mark the points and draw the lines. Here we show the table for only our station 3. Note that we have translated this in millimeter. Bud McIntosh called this laying down. He claims he did a 40-foot complete in 2 hours. Do not try that. Instead, take your time and get it right. Now take a different pen color, for example blue. We assume you have determined if you will use our method and directly draw the deducted table of offsets points, or you will draw original table of offsets points and an additional line for deduction. Start with the profile point at 0 on the vertical axis. Thereafter, the easy points like water lines and buttock lines, as you can see in your table. Next, the diagonals. Note in our table shown, the diagonals has an X and Z value. This is for plotting in Excel. Instead, take directly the value stated in the table of offsets. After this, take the other points depending on your table of offsets, like shear, cabin intersection, and more. In our table for Station 3, we have a deck beam as well. This depends on the station and your boat design. You must repeat this process for both left and right side. This is to be able to put the mold or real station on top of the lofting table. Now it is time to draw the curved station lines with the same pen color as the points. For this, take a batten, relative soft wood, or use a worn-out bandsaw blade cut as one long piece. Fit the batten with screws or nails on both sides at each point you have marked. Draw a line from start to the shear point. If deck curvature, draw this line in a similar way. Due to there will be so many lines, start with only a few stations first. We started here with 5 stations. When all stations are drawn, it will look like this. If you have choose to do separate line for planking deduction, you will need to use another color, for example red. Bud McIntosh method is to make arcs with radius equal of the deduction. But you can also mark these pretty accurate by just measure out perpendicular with a scale. If performed right, the errors will be very small. When performed for the initial stations, it will look like this. Note we have also marked the width of the station frame. 9. How to make and cut the molds. Now you have all curves, including the deduction curve for the first stations. However, how to use this? Well, we need to do a cutting mold for cutting the wood. The standard method is to use nails. Bud McIntosh used halfpenny nails with this rather large head pointing inwards, each with its head precisely located on the line. Give each head a hammer tap to set into the plywood and make it stay. Usually some nails want stay. A method to fix this is to use Loctite in the holes. Now, put a plywood or cardboard very carefully on these nails, wide enough for the station frame. Now walk on top or press down to get imprints in the plywood/cardboard. Lift it up and check how good the imprints became. If all is okay, it's time to draw lines between the imprints. For this, take a short ruler or similar and draw lines. Now it's time to cut out the mold. For this, take a ruler again and use it as in support when cutting. Use a pretty good cutter tool. For you that are doing boat build with temporarily molds on keel, here is some picture, How to Build a Wooden Boat, by from Bud McIntosh. If you want more information, just buy the book. The first pictures show how to trim the side of the mold with imprints from the nails. The second pictures show how to assemble. And final, the finished mold will look like this. 10. How to check the molds on the lofting table. Take the mold and place on top of the markings. Check if there is any mistake. If so, make a mark on the cardboard molds for adjustment. If your build is molds on a keel, also check like this picture from Bud McIntosh. If not satisfying, mark out with a sign and maybe some words what must be changed. You also loft all other needed pieces like reinforcement frames, bulkheads, bow, keel, and transom. Here is shown our molds for bulkheads on Station 7. Due to space limitations in the latter phase, we had to make it in 2 parts. If everything is okay with your mold in cardboard or plywood, you can now mark on the wood for cutting. Here, it's shown markings for one of our station. Note the reinforcement frames on the upper wood piece. A last thing, station frames like this in the picture, you cut with a bandsaw. Bulkheads you cut with table saw or a circle saw. This is the end of this ultimate guide in lofting. Thank you for watching.